Hi everyone, welcome to Jerematics Tutoring. In this video, I'll be talking to you about changing base. This is the second video of the Logarithms and Exponents playlist. This video is based on Chapter 2 of my book, Jerematics Logarithms and Exponents. This entire Logarithms and Exponents playlist is based off of this book right here. My next playlist will be Jerematics Trigonometry, and the Trigonometry playlist will be based on my publication, Jerematics Trigonometry. And all of my other videos regarding high school math, they're all based on high school math made understandable. And this book, Logarithms and Exponents and Jerematics Trigonometry, are actually adaptations from high school math made understandable, except these books go in more detail into specific subjects. So in this video, changing base, I will be talking to you about changing the bases, and we will start from the basics. So the first example I'm going to give you is what a base is, just to refresh your memory on this. In this example, 2 squared, this is the base right here, and this is the exponent. I know I picked the same number, but this is what a base is right here. It's at the bottom, and the exponent is what's at the upper right hand corner. So 2 squared, what is 2 squared? That's 4. When I ask you to change the base, what does that mean? Well, you have a number 4 right here, and say for example I asked you, well, I want this in terms of 2. How would I write this in terms of 2? Well, look at the other side of the equation, 2 squared. So would that be true to say that 4 can be written as base 2, 2 squared? Yes, so that's exactly what I'm asking you to do, is to convert it to a base 2. So you find an exponent that works out back to what you started with. So to explain this like a little bit more clearly, let's give another example, 9. If I ask you to write that as a base 3, how do you write that? You write that as 3 squared, because 9 is equal to 3 times 3, which is 3 squared. So this is 3, this is 9 as written as base 3, 3 squared. Now I'll give you a few more examples. I'll give you the example of 27. Let's write 27 as base 3. Is 27 a power of 3? Yes, it is. It's 3 cubed. So I can write that as 3 cubed. 3 cubed. So 27 is base 3. It's written as 3. What about the number 8? I want to write the number 8 with a base 2. How do I do that? Well, is 8 a power of 2? Yes. You can actually write 8 as a power of 2. So 2, that's 2 cubed. Because 2 times 2 times 2 is 8, because 2 times 2 is 4, times 2 is 8. So 8 written as base 2 is 2 cubed. So this is what changing the base is all about. It's about taking a larger power and then writing it as a smaller base. Or in some cases, you'll get something like this. I want to write this as base 5. How do I do that? Well, if you remember from the last video, there was something called the Negative Exponent Law. And you can represent a fraction as a negative exponent, and you can represent a negative exponent as a fraction, vice versa, right? So right here I have 5 to the power of negative 1. So this is how I'd write 1/5 as a power of 5. And now, if I ask you to write 1/4 as a power of 2, well, what do? The first thing you do is convert this to a negative exponent. 4 to the negative 1, right? And now I want to convert 4 to base 2. And if you remember from the beginning of this video, I said that if you want to write 4 as base 2, you would write as 2 squared, because 2 times 2 is 4. Because you want to find a base and an exponent that works out to what you started with. Because 4... Watch. Because 4 is equal to 2 squared, which is equal to 2 times 2, and it works out to 4. So 1/4 here is equal to 4 to the power of negative 1, and if we substitute this in here, because 4 is equal to 2 squared, we get 2 squared, and then there's a negative exponent, right? And this will give us 2 to the power of negative 2. So 2 to the power of negative 2 is how we write 1/4 as a base 2. So that's how you do that. Yeah, so now I will give you a few examples where you have an exponent that's a variable expression, and then you need to convert the base. So that might sound a bit confusing to you right now, but once I write it down and explain it, it should be more clear to you. So for example, I have 9 to the power of x plus 2, and I need to convert that to base 3. So convert to base 3. Okay? So 9 to the power of x plus 2. 9 is equal to 3 squared, if you remember from the beginning of this video. So 3 squared, that's 9. And then we grab this exponent right here and we put it on top. What's out of the brackets? Because we've converted our base to 3 squared, right? And then we have x plus 2, because that's the exponent up here. And then we use that law that I mentioned in the other video, the power of a power, because there's a power here and a power there. So we deal with that by multiplying 2 by x plus 2. We distribute our 2, the distributive property, and we get 3 to the power of 2x plus 4. So that's how you change the base if you have an exponent, like if you have a variable expression as your exponent. I will give you a few more examples, and then after that, that will be the end of this video, because this video is basically just a discussion about changing base. And in the next video, I will show you how you can apply changing base to solve exponential equations. So now I'll give you another example. Y. Now let's go with 1/16 to the power of 2x, and change this to base 2. Is 16 one of the powers of 2? Well, yes, it is. It's 2 to the power of 4, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 times 2 times 2 times 2 is 16. So 1/16 can be written as 2 to the power of negative 4, because remember that 1/16 is 16 to the power of negative 1, because you can represent a negative exponent as a fraction, and vice versa. So 16 to the power of negative 1. And now we add brackets and we raise it to the exponent of 2x, because our equation needs to stay the same. 16 to the power of negative 1 can be written as 2 to the power of 4 to the power of negative 1 to the power of 2x. What's 4 times negative 1? That's negative 4. So that gives us 2 to the power of negative 4, and we raise it to the exponent of 2x. And just to clear up any confusion that you may have right now, is I just want to repeat what just happened so you can follow along with me right now. Okay, 1/16, that's a fraction. We need to convert this to a negative exponent so we can simplify. So 1/16 can be written as 16 to the power of negative 1. So this gives us 16 to the power of negative 1. And as I said earlier, is you need to convert this to base 2. Not base 3, base 2. And you do this by figuring out a power of 2 that works out to what you started with, 16. So 2 to the power of 4 is 16. And we need to remember that we flip this over and convert it to a negative exponent. So we use the power of a power law, where it says that if you have a power and you're raising it to another power, then you multiply your two powers together. So we get 2 to the negative 4, because if you expand this, you flip this fraction, we flip it over as a fraction, so 1/2 to the power of 4, that's 1 over 16. That works out to what you started with. And now we have 2 to the power of negative 4 multiplied, well, to the power of 2x. So now we multiply 2x by negative 4, and this gives us 2 to the power of negative 8x, because 2x times negative 4 is negative 8. So we get 2 to the power of negative 8x. So thank you for watching, and if you have any questions, feel free to leave them in the comments below. And if you like my content and would like to keep up to date, then feel free to subscribe. Have a great day.